Well, hello all you cool cats and kittens. I can't even say it with a straight face. I thought it would be interesting to start off like that. Having to start off each video like that would be a little annoying. Alright, so today's lesson is all about the unit circle and reference angles. So let's start off by defining what a unit circle is. It is a circle with a radius of 1 unit. So what does that mean? Well, luckily we have a circle right next to the definition of a unit circle. So in this circle, let me just label some degrees. So this is 0 degrees, this is going to be 90 degrees, and that's going to be 180 degrees, right? So I'm going to draw any line from the center outwards right here, and any line that I draw from the center outwards, which is the radius, is going to equal 1 unit. And we can create a triangle based off of that. That'll look like it's going to be, they're all going to be right triangles because they come straight down. So theta is going to be our unknown. But then what is this point? Well, we can find that point by using cosine and sine. So it's going to be cosine of theta, sine of theta. That's going to be your point. And that's going to be very important once we start doing reference angles and finding out the point at which it's at. So let's get started. Let's do reference angle. What is a reference angle? I already mentioned it. So here's the definition. It is an acute angle formed by the terminal side of the given angle and the x-axis. So there's probably a word or two you guys don't know. Well, you guys should remember acute angle. If you don't remember, it's less than 90 degrees. So right here. And we're going to see why it's important later on. And formed by the terminal side. The terminal side is any length that you draw. So if I, like for the 45-degree reference angle, I want to make a 45-degree angle for theta. So my line is going to look like this, right? This is about 45 degrees. This is my terminal angle, which is also equal to 1 unit. Since I've already started there, let's finish this. Let's finish that. Let's use the formula underneath. Y equals sine theta, x equals cosine theta, and find x and y. And then we can find tangent once we have x and y. So let us begin. I'm gonna draw a dotted line straight down. It can be solid, and it'll create a right angle. That's a given. So based off of trigonometry, what do you remember? This will be a 45, 45, 90 triangle, right? So let's draw one off to the side. 45. So this means that this length is equal to that length. It's a right triangle. There we go. And here's 1. What does 1 equal? 1 equals x root 2. So if we solve for x, we can get these two side lengths, right? So 1 equals x root 2. X equals, because we divide root 2, 1 over root 2. But we can't have root 2 in the denominator, so we got to make it a proper fraction. So we're going to multiply both the top and bottom by root 2. So we're going to get root 2 over 2 equals x. So then we can put root 2 over 2 over here and root 2 over 2 over here. So now, what is my point using cosine theta and sine theta? What is my point going to be? It is going to be square root 2 over 2 and square root 2 over 2. This is what that point equals. I found that point on this circle. So now you're asking, well, why is this important? We'll get to that. Relax. The important part is about finding x and y, your x and y points, using a reference angle, like such as 45 degree. So remember, the line I drew was the terminal side. So over here, we're gonna do something called the bow tie with 45 degrees. So I could show you how the relationship between all 45 degree angle along the x-axis, because all of these, whatever line you draw, the second line that you're going to draw to create the right triangle is going to go down to the x-axis. So let's start. We'll put 45 first. That's around 45. I like to put the points first so I don't mess up. That's about 45. That's about 45, and that's about 45. So if I draw my second one, I can create a second 45 degree angle right here. Here's another one. And there's another one. But remember, they're all in reference to the x-axis. So you're never going to draw it going out towards the y-axis. That's a no-no. You're going to bring it up and go to this line. You're going to go down, bring it up there. You're going to go down there. You're going to bring that down over there to the x-axis and create another right triangle. You're going to go down and create another right triangle. And each one of these are all going to be 45, 45, 45, 45, right? But we know that it isn't 45. So if we start zeros over here, and in every unit circle, you're going to start from here and move your way up calculating the degrees, because there's 360 degrees in a circle. So if we calculate the first 45, it's 45. If we calculate up until the second point, that's 135 degrees. And then if we calculate all the way to the third point, that's 225 degrees. And then if we calculate all the way up to the fourth point, that's 315 degrees. So can we use this, the 45, 45, 90 triangle, to find x and y? Remember, y equals sine theta, x equals cosine theta, according to this. Here, just to show you how important it is, I'm going to highlight it. This is very important for doing the unit circle. So we're also going to be finding tangent using the bow tie. You see how it creates a little bow tie? So let's get started. What's 45? We already have the answers to that. We already know x and y. Square root 2 over 2, and then square root 2 over 2, right? All right, so x direction, it's going to be a negative, but it's going to go positive in the y direction. So our new point over there is going to be negative root 2 over 2, and then positive root 2 over 2. So your y is going to be positive. What do you think is going to happen in this quadrant? Right? Both of them are negative. Negative x, negative y. So it's going to be negative root 2 over 2 and negative root 2 over 2 for x and y. What about here? We get a positive x and a negative y. So the first one is going to be negative root 2 over 2, and then the second one is going to be positive root 2 over 2. Right? And then let's take it a step further. How do we find the tangent to each point? 45 degrees. So if I do, so let's do this. Let me find some room. So we do tangent theta equals y over x. So if I want to find tangent theta, all I have to do is y over x. So if I were to do this one for 45 degrees, what would it be? It would be square root 2 over 2 divided by square root 2 over 2, which would equal 1. So tangent is 1. What do you think it's going to be for 135? If I have one negative, so it's going to be a total of negative 1. If I have two negatives, positive 1. If I have one negative again, negative 1. So you can see how the negatives are kind of opposite of each other, like the positives are opposite of each other as well. But that has to do with the quadrants they're in, which let's go to it right now, into the signs, right? So in quadrant 1, sine theta is positive, cosine theta is also positive, tangent theta is also positive. Hopefully you guys realized it, but look, all of our solutions up here, they're all positive in quadrant 1. What about quadrant 2? Sine theta is positive, but not cosine theta. Cosine theta is negative, and because of that, we're going to have a negative tangent theta. So we can say that all here are positive. Only sine is positive, so I'm going to put an S. So what about quadrant 3? Sine theta is negative. Cosine theta is also negative. Because we have two negatives, it's going to give us a positive for tangent theta, which means only tangent is positive. Quadrant 4, sine is negative, cosine is positive, but tangent is negative because a negative times a positive, well, negative divided by a positive gives you a negative still. So the only positive one is cosine. So you could tell that only quadrant 1 has all of them to be positive. All the rest of the quadrants have one of them to be positive. Hopefully you guys were realizing it before I was doing it, doing it before me, getting ahead. Do that, get ahead, do it before me. So here, sine of 45 degrees. Well, we found sine of 45 degrees, which is the y value, which is root 2 over 2. What about sine of 315 degrees? Well, that's in the negative quadrant. That would give us, oh, I did it wrong. My bad. So it's not negative root 2 over 2 for the x, it's negative root 2 over 2 for the y. Some of you guys might have caught that already and were hoping I would have caught it. I caught it a little later. I apologize. Sorry for that. So sine 3 of 315 degrees would be negative root 2 over 2. What about cosine of 135? Well, if we look here, cosine of 135, the x value, is negative as well, negative root 2 over 2. Cosine of 225, we already did it. It's right here. It's negative because they're both negative, so we're good to go. Tangent of 45 degrees, positive 1. Tangent of 135 degrees is negative 1. And then tangent of 225 degrees is also positive 1 because you have two negatives. And then tangent 315 is negative 1. So if I give you something like this through unit circles, you can still calculate it. All right, let's move on to the second page. This is always the longest part. Well, it seems long because we're not doing anything. Right? Right. See, you guys can't argue with me because I can't hear you. All right, let's do it. What do you guys think? 30 degrees reference angle. What triangle are we gonna possibly use? That's right, 30, 60, 90. So let's get started. So if I draw a line 30 degrees above the x-axis, it's gonna look like that. 30 degrees, one unit, bring down the line, create a right triangle. There we go. All right, so now we gotta find x and y, right? So let's create our 30, 60, 90. 30, 60, 90. So if one's here, what are my my other two sides? If you remember the 30, 60, 90 triangle, so across from 30, it's going to be 1/2. And then the ratios of 30, 60, 90. I hope you guys remember. I hope it's coming back. I know that, if you haven't used the NOI, you'll forget it. But I hope you understand from integrated 2 how we came up with those. So if we go across from 60, it's going to be square root 3 over 2. Right? If you have any questions, ask me when we see each other next. So our x is going to be square root 3 over 2, and our y is going to be 1/2. So a little bit different than the 45 degree reference angles, right? This is our terminal side. Remember, the side that we draw above the x-axis is our terminal side. So let's do our bow tie for 30 degree. And it's going to look more like a bow tie than the 45 degree one because it's going to be a little bit longer, elongated. So I'm going to write this up here so to remind myself, cosine theta, sine theta, right? That's the x and y. X is cosine theta, y is sine theta. So let's go, let's do it. So here's 30. There's 30. Maybe not so 30, but a little bit lower. There's 30. and there's 30. So if I draw an ugly bow tie. And then I'll make the bow tie right there. Not very equal at all, but I know that's 30, this is 30, that's 30, and that's 30. Right? 30 degrees on all sides, but the total degree measure is going to be different. So remember, where do we start? Right, 0, and we move counterclockwise. So we go left, move up and left. So this is 30 degrees. This is going to be, 150 degrees because total is 180. Subtract 30, get 150. Then 210, 180 plus 30 degrees gives you 210. And then the last bit is 330 degrees because total circle is 360 degrees. Subtracted by 30, you get 330. All right, let's find sine, cosine, and tangent like we did before. So let's just do all the cosine and sine first for all of them. So we do square root 3 over 2 and 1/2 because we already did it. So what do you think is going to be on 150? I already told you. Cosine is going to be negative because we're going backwards in the x. So what do you think? They're both going to be negative at 210, quadrant 3. So negative root 3 over 2 and negative 1/2. What about 330 degrees? It's going to be the y is going to be negative, not the x. Like I made that mistake on the other page. That was my bad. I'll take that. That's all me. So let's do tangent of 30 degrees because we find one, we know the answers for the rest of them because we know the positive and negative, what cancels and what would give us a negative and what would give us a positive when we divide them. So it's going to be 1/2 divided by square root 3 over 2. And some of you guys are like, well, why am I writing it like this? So I could do copy dot flip. It'll be a lot easier than putting it above each other. 1/2 times, because I copy, and then I flip the second part, 2 over root 3, which would give me 1, because the 2's cancel, 1 over root 3. But is that proper? No, I have to multiply the top and bottom by root 3. What do I get? I get root 3 over 3. That is my answer. Tangent is root 3 over 3. All right, what is my tangent for 150 degrees? Right, negative root 3 over 3. What do you know? What do you think is going to happen at 210? It's going to be positive root 3 over 3. Oh, what do you think? Is going to be positive or negative at 330? Right, negative root 3 over 3. So now, does this look very similar to our 45? Oh man, I wish it was copied both front and back, but it isn't. Let me pull it out. Would you look at that? Here, let me put that right there. Right? I hope they're both in the shot, right? Because we have positive, negative, positive, negative. Right here we have positive, negative, positive, negative for our tangents. You think this ratio is going to continue? You're absolutely right, it's going to continue for the 60-degree reference angle. So let's continue. Let's do this part. You guys are like, well, I know what they equal. All right, let's just do them pretty quickly. Sine of 150 degrees, 1/2. Well, it is a video, so you could skip over this, which many of you are, if you already understand it. If you don't, remember, sine of 150, my y, right up here, my y. Y, 1/2. I mean, right here, 1/2 for 150 degrees. There we go. Sine of 330, find 330 degrees. And I'm going to find the y, negative 1/2, right there. So negative 1/2, and I'm going to continue to do that. Cosine of 150, negative root 3 over 2. What about cosine of 210 degrees? It's going to be also negative 3 over 2. What about tangent, the tangencies of 30 degrees? Well, we already found it. Positive root 3 over 3. Tangency of 150, negative root 3 over 3. And then 210 is going to be positive root 3 over 3. And then 330 is going to be negative root 3 over 3. Good job. All right. So now we have to do the 60-degree reference angle. And it's not any different. Not in the least bit. So let's do it. So it's going to be way up here. Bring it down, create my terminal side. then bring down, create a right triangle with the x-axis. There we go, bring that down there. I know that my radius is 1, but now, do I remember what a 30, 60, 90 triangle is? Well, we already did it up here. Right across from 60, opposite of 60 is square root 3 over 2. So I know that this side is going to be root 3 over 2. I know that this side's going to be 1/2. Here, I'll write 60 degrees because this side's 30. Right? So what's my x and y? X is 1/2. Y is root 3 over 2. And you're thinking, well, our tangent is going to be the same. No, because we flipped x and y, and they're not similar. They're completely different. One has a root 3, the other one's just half. So, if we're going to do tangent of 60, let's do it right here. Tangent of 60 degrees equals square root 3 over 2 divided by 1/2. And then we're going to copy dot flip, which we get root 3 over 2 times 2 over 1. 2's cancel, and we get just root 3. Root 3 is our tangency for that. That's it. All right, so let's create the bow tie on the right-hand side to show for all 4 quadrants. 60. 60 is about here. I want to say up here, up there. I'm trying to make it as equal as possible to get that really good bow tie shape, but that's really, really difficult. There we go. This is a lot better. Right? Wouldn't be caught dead wearing that at a wedding. That looks like a 7. Well, I was laughing at my own joke. Alright, so same thing. They're all right angles. Right triangles. There we go. 60, 60, 60, and 60. Right? All of them are 60. So let's find x, y. But now 60 degrees is right here. But if we go further, it's going to be 120 degrees. If we go over here, 240 degrees. If we go here, 300 degrees. That's how far we're starting from here and going over throughout the circle. So how many degrees is it from here to here? That's 180. So what about till here? That's 60 degrees. If we start from here, we go there, that's 120 degrees. If we start from here, we go over here, that's 240 degrees. And if we go from here to all the way over there, that's 300 degrees. We're not taking any shortcuts and going left. Unless it's negative degrees, which, you know, when we get there, we'll do an example with it. So, let's go 1/2 square root 3 over 2, because we already found it. It's right there to the left. We already did it. Square root over 3. I mean, root 3. All right. What do you think 120 degrees is? Right. The x is going to be negative. Cosine is going to be negative. And then it's going to be root 3 over 2. I wish I wrote that smaller. Sorry. Sorry about that. I hope you guys can still see it. Yeah, I can still see it through the video. And then this is going to be negative root 3. Right? What about 240? It's going to be negative 1/2 and negative root 3 over 2. So we're going to have 2 negatives. And it's going to be positive root 3. Right? Tangency, we already saw the pattern in the last one, compared it to our pattern from 45 degrees. So it's safe to assume that 60 degrees is also going to be the same pattern. So let's do 300 degrees. It's going to be 1/2 and negative y. I made that mistake once. I ain't going to do it again. And negative root 3 for the tangency. So let's find our sine and cosine and tangents for each of these angle measures that it gives us. So 300 degrees, negative root 3 over 2. Right? Just look at it. Look at the x and y. Sine of 120 degrees, square root 3 over 2. Let's find it right there. We did it right. There's y. Cosine of 60 degrees is 1/2. 60 degrees, yep, 1/2. Cosine of 240 degrees, negative 1/2. Well, yep, right there, negative 1/2. That's how I found them. That's how I'm finding these. Tangent of 60 degrees, square root of 3, right there. 120, negative root 3, because it's going to go in the circle, so it's going to be positive root 3. And then 300 degrees is going to be negative root 3. All right, So now we're on to 90-degree reference angles. And you're like, well, how can we draw a right triangle if we're gonna have to place our point here, 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 and here? Those are all 90 degrees apart from the x-axis, right? Well, you have to include 0 and 180. So we have 0 degrees, 90 degrees, 180 degrees, and 270 degrees, right? So we have an x, but we don't have a y. So it's gonna be 1, 0. Because remember, the radius is always 1. R is 1. This is 1, that's 1, this is 1, and this is 1. If we draw the lines like that, right? That's where we get the 1 from. 0, because there's no height. So what about 90? There's height, but there's no distance or length, right? So since there's no length, we can say 0 for x and 1 for y. What about here? It's in the negative direction. So we can say -1, 0. What about 270? It's going to be 0, -1, because it goes down 1. Now, how do we find tangent of 0 degrees? Well, that equals 0 over 1, right? Y over x, which equals 0. Here's the tricky one. What about tangent of 90 degrees, right? It's 1 over 0. What does that equal? That's undefined. It does not exist. So let's label them. 0, undefined, 0, and undefined, right? It's okay to write it as undefined. We're showing that you know, it doesn't exist. So sine of 90 degrees, 1. Sine of 180 degrees, 0. 180, the y, 0. Cosine of 360 degrees. Well, 360 is back at 0. 0 and 360 are the same. So cosine 360 is 1. Cosine of 270 is, it's going to be 0. Tangent of 90, undefined. We already did it down here. What about tangent of 180? 0, right? We already did it. 0. Tangent of 270, undefined. And then tangent of 0, 0. All right, so tangent of 630 degrees. So this one's a bit tricky because if we go through we're up to 360 degrees. So we have to, what if happens if we go another 360 degrees, right? It starts over. Once you hit 360, it starts over. So we do 360 plus 360, right? You get 720. So it's gonna be under. It's gonna be under the It's gonna be in between 360 degrees and 720 degrees. So it's gonna be another full circle. So if we do 720 minus 630, whoops, 720 minus 630, whoops. 720 minus 630, you get 90 degrees. And because it's undefined at 90 degrees, it's also going to be undefined at tangent of 630 degrees. So just remember that the circle keeps going. You can have over 360 degrees. You just have to recalculate it into the new, you go, like if you go past 720 degrees, you've already went around the circle twice. You're just gonna go a little bit into the third time for 720 degrees. Something over 720 degrees. So we could say that 630 degrees is coterminal with 90 degrees. It's a coterminal angle, meaning it's going to end up at the same exact spot as 90 degrees. Therefore, it is coterminal with 90 degrees. I hope that makes sense, the term coterminal, because that's what it is. Coterminal to 90 degrees, that's what 630 degrees is. That's why it's undefined. It has all the characteristics of 90 degrees with unit circles. All right, let's move on. This is going to be a long lesson. I'm sorry. I hope I'm not boring you. And if I am, You could fast forward. I hate saying that, but it's true.